So here we are in the cockpit, the Boeing 777-300 TRX. You may see maybe the overhead panel here. We're just ready before takeoff. We're showing some of the systems, the Boeing 777-300 TRX. You can see the flight directories on there. So you see here the engine here. As we move the engine, the thrust increases rapidly. So we have the takeoff thruster. So this is the cockpit, the Boeing 777. Hello there, I'm Thomas Hatsios, the pilot captain flying the Boeing 777-300 TRX. So in tonight's flight we're gonna be flying from Zurich International Airport over flying Switzerland and Germany, and then coming back flying Switzerland back to the Zurich International Airport. So right now I'm in the cockpit of the Boeing 777-300 TRX. So I'm gonna show you these aircraft systems and how to use them before flying and during flight, how to start up the engines, how to set up the autopilot and the flight control, how to use the flight control column and control wheels. So right now I'm going to show you the primary flight display with the airspeed and the barometric altitude, the speed guidance of the aircraft with the flight director and the flight mode annunciator, the rate of climb and descent, the barometric setting, pressure setting, and the magnetic truth heading and the radio altitude. Now we have the flight mode annunciator in the primary flight display with the auto thrust and the autopilot modes engaged. Later horizontal and vertical modes for flying. So you can see in the navigation display I'm going to show you we have the GPS map with the terrain, the elevation of the terrain displayed with colors green, red and yellow, and also the water with the blue in the sea. And we have also the airports, the navig, the board, ADS and DBs and the waypoints. So we also have the ECAS, the upper ACAS engine indication controller system, the lower ACAS that displays the engine's data displayed through the which are controlled and monitored by the FADEX, which are the full authority digital electronic control computers, which are controlled by the engine electronic computers in the overhead panel switches in the normal and alternate mode, and they control the engine thrust, the fuel flow of the engine temperature, its limits, the N1 and the N2, the high pressure and the low pressure stage and speed of the starter of the turbofan compressor and turbine stages of the turbofan engines, the GNX engine. So we have also other displays from the FADEX like the oil of the engine, the fuel flow in 1000 kilograms per hour per engine, and the vibration from the engine vibration. So we also have the flight management computer. We're going to use the flight management computer to set up a flight plan, which is going to be displayed through waypoints and vertical and horizontal fixes on the navigation display. We also have the autopilot and flight director system control panel with the auto thrust. We have the auto thrust system, dual channel. We have an autopilot, and also we have the autopilot disconnect buttons. We have other buttons like and switches for the autopilot, like the altitude, the airspeed, and the heading and the vertical speed, the rate of climb and descent, and the disconnect button for the autopilot, and also the flight director and the auto thrust. So I'm also going to be showing you the thrust levers, how you use the thrust levers to set up the engine thrust during the flight. So we have less than 1 hour for this flight, so we're going to be very fast. I'm going to show you the overhead panel, the electrical system with the left and the right engine with the three drive generators, which are connected to the engine engine it's a kind of external connection with an IDG, the great drive generator. So it has a lot of explanations, so I'm gonna do it in another slide. So we have the APU, the auxiliary power unit, the batteries for electrical power. The APU, the auxiliary power unit, is gonna use for stuffing the engine using the compressed air. It produces, also gonna show you also the hydraulic panel, the left and right engine hydraulic pumps, the secondary left and right C1 and C2, and also I'm gonna show you the fuel pumps and tanks panel, left and right wing, the fuel quantity and the center tank, also NBX feed and the fuel pump. We can dump the fuel required. So I'm going to show you some of the flight controls, the radio communication panel, the transponder with the TCAS, the traffic collision alert system, and also the flaps and slap levers, the thrust reversers, the auto thrust disconnect buttons, and the takeoff ground button. I will also show you how to use the control column and the control wheel for controlling the aircraft flight control, the ailerons and the spoilers in each wing, and also the horizontal stabilizer elevator and the rudder pedals. And all that I'm gonna use the side stick to show you. So I'm also gonna be showing you how to use I'm gonna do very fast explanation of starting up of the engine right now in this flight. So I'm also gonna be showing you how to use the rudder pedals for the rudder and how to control the aircraft in flight, the other of the aircraft when flying. So by changing the aerodynamic pressure in its wing control surface, we find the aircraft by having by producing aerodynamic lift in its wing, left and right wing. So by accelerating the aircraft in V1, V rotate, and then V2 airspeed in the runway. So I'm gonna set up also this the flight management computer for takeoff, and show you how to do that with the flap settings and the center of gravity using the aircraft weight and fuel calculation and the mean aerodynamic control. So right now I'm going to show you how to use the flight controls very quickly, and then make a sort of brief explanation of the aircraft system. So thank you very much for watching me for this flight. I'm Thomas, Hatsios, the pilot flying the Boeing 777-300 So I'm gonna start right now. So you can see here we have the control column for the elevator and the control wheel for the spoilers and the other ones. We also have here the slots. We have the speed brakes actually, and here is the flaps and slot lever. We can move this down to extend the flaps and the slots. You can see outside the aircraft view. We have flaps and slats extended, and also the speed brakes. So we also have the elevator, the rudder. You can see the control surface moving. I'm gonna show you now very quickly how to use this control column and control wheel. I'm gonna show you right now how to use the control column and control wheel using the side stick I use for the Airbus aircraft. This is used also for the Boeing aircraft quite well. It's quite simple. So you can see here we have the side stick surface for the Boeing aircraft. You can see I can so perhaps you can see a better view right now. Pitching up and pitching down the aircraft using the side stick, and also bang rolling the aircraft left and right using the side stick and using the rudder pedals like that, and also having the thrust. You can hear the thrust lever. So pitch up, pitch down. We have the trim position here and the flaps and stuff. So we can use it for the stabilizer trim of the aircraft. So you may see here the control column, as I said, is proportionally, I'll show you here the flight control page in the systems displaying data. So have the display, synoptic, flight controls, Very simple. We can see if I move here the control wheel and column, speeds up, speeds down, barrel left and right. We also have the display here. You can see if the hydraulic and the electrical system is working, because we have flight control computers. This fly-by-wire aircraft, the Boeing 777, as you can see. So the surfaces are electrically controlled but hydraulically actuated, just like the Airbus A340 and A330. So you can see the stabilizer position. Here is the spoiler. If we extend the speed brakes, we have more spoiler movement. The ailerons and the flaperons, the outboard and the inboard, left and right, the stabilizer position, the rudder trim, and the flight control modes is normal right now. So hopefully you have a nice view here for the flight control. You can see the elevator moving up and down and the rudder, just like the original Boeing aircraft. So you can see here we have a pitch up and pitch down for the aircraft, and also bung roll. So here we are, we have the trim. So you can see with the input from the side stick is proportional actually into the control wheel and control column. And we also have some other, I'm gonna show you now very quickly. We have the flight control surfaces here. You can see the ailerons and the spoilers all moving in the wing. The elevator position, pitch up and pitch down. We can also trim up and down the horizontal stabilizer. All the surface is the horizontal stabilizer, and the moving up and down is the elevator. So we have the rudder here, a triple rudder. You can see using rudder pedals, and here's the ailerons with the flaperons, the inboard ailerons, and the outboard ailerons. So one more view here, and I'm gonna start the engines now. I'll do very brief flight. You can see pitch up, pitch down, bung roll left and right, rudder pedals, and the engine, and pitch up, pitch down now. The aircraft position. So you can see the proportionality between the side stick position as I move in degrees, pitch up, pitch down, and bung roll left and right. And as I said, this is fly-by-wire aircraft. So it's controlled by its center of gravity and G acceleration, the acceleration of during flight in gravity acceleration. So in G's. So you can see here. So I'm gonna start now more about the inside of the aircraft, because we have not much time left for this flight. So you know most of the stuff about the Boeing 777. We have less than 40 minutes for this flight actually. We have to be very brief. So you can see here is the overhead panel. You can see here we have, as I told you, it's the displays for the indications of the aircraft. So we have the modes, we have the status page. We can turn on the APU here. You will see we have the hydraulic, the pressure in PSI, the cabin oxygen, the crew pressure of the oxygen, the crew oxygen pressure also. So we have the start switch here for the APU, which is we're gonna use to compress air. Compressor from the APU for starting the engine, and also electrical power of the steering, like 75,000 kilovolts, so 75,000 watts. We have the left and the right engine. You can see here the batteries, the APU and the primary battery. We use the APU battery for starting the APU. So you can see here we have the APU is increasing its rotation and temperature, so it's gonna be available in like a couple of minutes. So we have here some other modes. We have the checklist, we have the normal menu, the pre-flight, before start, like what we need to do before starting the engines. So you can see if we put a tick here in every part, the checklist is complete. So you can see for the Boeing 777, this is the normal menu. Before takeoff, before start the engines, you can see checklist is complete here. The message is being displayed, is coming on, what we need to do. So we have also the abnormal. In case of an emergency, we need to know something about a failure in the aircraft, something not going well, like the automatic flight. You can see we have here is the autopilot. The autopilot disconnect. If something is wrong with that, the autothrottle disconnect. The autothrottle left and right, no autoland, no run 3. So we have 3 autopilots. So here we have the autopilot condition 1, mode 3, and here what we need to do. So we have the electrical. What we need to do also, we have like an AC bus left fail. So you can see we have more information here. We can drag this down, this checklist down. So you see, maybe a few more minutes left. Checklist again. We're going back into the normal menu. We have the resets here. So we also have communication checklist here, the air traffic control panel. We have the synoptical, we have the doors are closed. You can see we can pressurize the cabin of the aircraft when the doors are closed. We have the tires of the aircraft and the wheels and the brake temperature, the electrical. Other tools in the overhead panel. We have the display also here. So we need to be very brief. You can see the left and right engine. You can see the whole diagram here in the electrical ACAS synoptics. So you can see the left and the right engine, electrical power disposition, and with green is working and the white is not supplying. So the APU is also working but not supplying the electrical system. We have the main battery volts, 26 volts fiber. We have a lot more. We have 115 volts, 400 hertz frequency, 75,000 kilovolts. From the alternate current, I believe we have like about 45 minutes left for this flight. So we have the hydraulic system. You can see 3000 psi left and the right engine, compressors, the fuels, the set-off valves for the hydraulic fluid in case of an emergency, and the left and the right electrical backups for the hydraulic system with their own psi, 3000 psi. And we can see the flaps, Lszh, flight control, nose gear and landing gear, and steering and brakes, and also thrust reversers. We use for the thrust reversers this hydraulic system fluid. So we go very quickly now. We have the fuel panel here. You can see the fuel level. The APU is dragging, and the engine, you can see the green line, is consuming fuel. Left and right wing engine, 27,600 kilograms each one. Forward and aft pumps, and the fuel level 55,100 total. You can see the left and the right engine symbol here, and the valves, the low and the high pressure valves, the crossfeed valves are off. So you can see the center pump is empty, so it's displayed with the yellow crosses. You can see the air compressor from the air engine, which is used for the hydraulic fluid tanks compressor, and also you can see it's used for cabin pressurization when flying, pressurize the cabin of the aircraft, and for the ice system, and for air conditioning and ventilation. So You can see the left and the right engine symbol, the intermediate and the high pressure stage. We have the bleed valves on or off. So you can see the APU valve bleed is off right now. We have no APU and white instead of green. We have green from the engine applying all the systems I told you, and the temperature inside the cabin. It's different temperature for the as you can see, if I increase the thrust levers here at the engine, we increase the pressure in the engine. You can see the duct pressure increases from 36 up to, this is left engine, right engine, it may increase a lot to about 50, 60 psi, 70, maybe 80 psi. While we decrease the thrust levers, you can see more engine thrust, more air into the system, more compressor and higher temperature. So I'm gonna show you now the rest of the system. There's nothing left from the flight controls. I will tell you, we saw the flight controls. I will go back to the modes, the checklist. I will tell you, we have the normal checklist. We have the communications here for the air traffic control. Flight information, manager, company. So checklist, normal menu. I'm going back maybe to the engine for starting the engine. I'm going to show you how to start the engine very quickly. I have not much time left. For this flight maybe like 40 more minutes. So here we are. We're going to start the engines now like a couple of minutes. This is the Boeing 777 on upside view. Beautiful wings. How huge this aircraft is. 75 meters long, approximately, maybe 76, and wide. So I'm gonna show you only the overhead panel and how to start the engine. So show you a better view here. The upper panel, you can see the inside of the cockpit of the Boeing 777. A much better view here. So you can see the communications panel. You can see here we have the disconnect switches for the electric trim for the auto thrust and the autopilot. We need to have electric trim for the tail of the aircraft, the stabilizer of the aircraft. You can see the symbol again, the Boeing 777. You can see the thrust levers. I move the thrust levers. You can control the aircraft from this view actually. So I'm gonna be very brief. You can see here we have the autopilot, the auto thrust. We can turn on and off the auto thrust. The autopilot on and off. We disengage the autopilot like that. We have the airspeed here. We can select the airspeed, higher airspeed, and then depress the button maybe. Here, this is the pressable button. We have the heading hold switch. And select the heading. For the runway, and also have this this is for the bank hole when it's flying using the autopilot. We have the automatic. So this is the vertical speed switch for descent or climb, the rate of climb and descent feet per minute. The altitude hold, we can increase the altitude and say it's what we want, 1000, so we'll increase to maybe 35,000. You need to press the switch and here select those. So this is so much for the autopilot. You can see the flight director here on and off. So we go overhead panel again. This is the air data enhancer reference system that displays I forgot if not have done this that displays the information you see here, the airport. So we need just to make a small input here. Initial reference menu. I can see we need you can see the model, position, initialize, reference airport. This is applying the GPS position and also barometric and anemometric data. GPS position, set inertial position here, and we set the GPS position as inertial, so we have the position of the aircraft in 3 seconds, maybe 20 seconds, so we have to go back. This is going to align, you can see the GPS. So this is what it's actually doing. This switch over here, we have the display of the GPS position, the terrain, the airports, the barometric altitude, the gyroscopic precession, all the data here displayed, the airspeed and the angle of attack of the aircraft as it flies. So here we are, it displays in all this and also supplies to the flight management computer and the autopilot and auto thrust and the FAREX. So we have the electrical here, you can see the left wing and the right wing engine electrical integrated drive generators. We can disconnect them if we want. We have primary flight computers, we have flight-by-wire aircraft, as I said. This is the window sheet, this lights, oxygen, hydraulic, see left and right engines, hydraulic pumps. You can turn in the off also. And we have also this the electrical backup. So we have the electrical engine control computers for the FADEX of the engine, for digital engine control computers. We have the engine starter here, we have it on and off. We can dab some fuel if we arm the switch in flight, and we'll select the nozzle to dump the fuel and increase, decrease the quantity. We have the left and right wing pumps, the crossfeed valves. We control this, and the sender tank of the aircraft and the fuel inside. So we have the lighting. Here's the cabin pressurization. We can turn from auto to manual and use these switches to control the aircraft pressurization as we climb or descend. We have the left and right engine and the APU compressed air, supplying compressed air for the hydraulic fluid, for the cabin pressurization, the LEIs, and some other systems like the air conditioning. So we're gonna be very quickly. You can see the communication panel that here we have the fuel cutoff levers for the engine. So we're gonna turn off the fuel levers. So everything in the overhead panel is set correctly, as you can see, and the cockpit. So we can start turn off the engines now and start them up again. We hopefully do it very quickly because we have not much time. We will turn off the fuel sort of valves left and right engine. So you will see, you can see the flap position here. You can see the cabin pressurization of the aircraft, automatic and cabin altitude, total fuel and temperature, and the fuel quantity. We have the N1, the low pressure, low speed compressor stage of the engine. We have the engine shutdown message. This is the Boeing 777. So we come in the outside view. You can see the left and the right wing engines slowing down. So we're gonna have no engine spin in like a few seconds. We have no engine spin right now. So we go back inside. You can see the left wing engine here, no spin. We only need to do one automatic setup. You can see the reconfiguration. The electrical, we have no engine left and right or sender on the engines. Electrical power alternators, some hydraulic, maybe the engine bleeds here are off for starting the engine. Some isolation valves are reset, so we start the left engine starter first. Select the left engine. So you may see here we have the left engine and one increasing. Also the temperature, here we have the N2, which is the high pressure, high speed rotor stage of the compressor, and turbo and turbine of the turbofan engine. So you can see 32.6%. You can see here the spinning increasing to the left wing engine. You can see also here the left engine going on, increasing in speed. So we go back inside. The only thing we need to do is let the left engine set off valves, fuel set off valve turn on. So we're gonna have the fuel running into the engine. You can see we have no fuel on this side, the right wing. We have fuel 0.700 kilograms, 800 per hour. So you can see the end the spinning increasing here. We have the engine ready. So we'll go back into the other side engine. This is the wings view here. Here's wings. Here's engine. So we have the other side engine now still as you can see. So we have to start very quickly. You can hear in the overhead panel here in this switch. So in the start position we have the right wing engine start process now. The FADEC is working, so we have also the engine starter compressor from the APU, 33% N2 stage. You can see the spin is increasing for the right wing engine. So we go here in this view. Something is working out, but we still have no fuel, not much fuel for display 0. So we can here again start the fuel set off valve. We have like 30 more minutes for this flight, so we need to be very brief. So we start the right wing engine. You see the N1 and N2 increasing very rapidly. You can see the outside view also. We have the engine spinning. The right wing also. And here we go. We are ready for takeoff. So we are here. It was ready for takeoff. We'll need to complete one last step. So the runway is open for us right now. We have no other traffic. I'm gonna use this view. You only need to set up the flaps here at position 15 degrees. Hopefully 15. Here we go, 15 degrees. This is the 15 degrees, 5. So you only need to set up the flight management computer. You can see all the modes almost ready. So we're gonna have the initial reference, the zero fuel weight, and the gross weight with the fuel here. And we have the reserve fuel for this flight 5%, and the cost index and the flight altitude set from the previous flight 35,000 feet, the temperature minus 37 degrees, gross weight center of gravity 7.5%, with the flat center of gravity again. We're gonna use first the route LSZ8 very quickly to LSZ8 again, copy paste and the runway 14. So we use the departure here, this runway 14. and this fix and the price of arrival again. Lszh Transmegrio on Alpha Transummit. So let's close the discontinuity and activate. So we have the thrust limit here, 80 degrees, the flap center of gravity, 32%, and we have the V-speed automatically for takeoff. We have V1, 176, V-rotate, and V2, 157 with gross center of gravity, 4 degrees for the horizontal tail of the aircraft, 4 degrees off. Center of gravity, mean aerodynamic chord, 27%. So you can see here we also have the flight director mode, and we have the ILS localizer needle, so you can see the map here. I'm gonna show you the plan we created in this view. So you can see this the flight path we're gonna follow, the fixes. Maybe a little bit closer. Yeah, you can see better view here of the fixes after takeoff, then taking a turn and coming back into the airport. You can see other airports around this, other maybe the waypoints, we don't need so many waypoints, it's more confusing. So we go back into this view. As you can see, the radar here is ready. So we only need to disconnect the parking brakes, increase some thrust, and we are ready for takeoff. We have like 30 more minutes for this video. And we use this tiller to control to steer the aircraft in the ground. Right, so therefore we have some velocity from the engines running. You can turn the aircraft using this control wheel here, the tiller. So there is no traffic now. It's used from the other runway. So here we go again. We have like 30 more minutes for this flight, as I said, so we need to be very brief. Maybe we're gonna make it faster, so need this control wheel here. Maybe you can see here we have the Mediterranean Sea. So use the parking brakes again. You can see the flight director, we have the ILS on, the needle, and we have the mode for takeoff pitch, like 8 degrees. We need to pitch up to avoid a tail strike, like only 8 degrees, the control column. We need not to pitch up too much for this takeoff aircraft. So we have the ILS here, the radio altitude, the airspeed selected, and the altitude selected from the autopilot panel. We're going to use a bit more airspeed. And the heading of the runway. You also may use the LNAV along with the altitude hold remotes. The autopilot is off. So maybe you're gonna see here we have our position here. So we only need so you can see the Boeing 777. Just need to align a little bit to the runway and go for takeoff. So if we increase the thrust levers here, the thrust, you're gonna see we have an increase in thrust here engine. We need to stabilize the engine. You can see the terrain map here. I'm gonna change the view a little bit closer. We don't need to look all the way down to the sea. And this is okay forever now for the takeoff. So we disarm the parking brake here and go. We have maybe like 30 more minutes for this flight. Exactly 30 minutes. So we need to be fast. Advance a little bit further as probably the maximum takeoff, go on power. Let's see if I'll use this later for pitching up the aircraft. So you can see we have 78 knots, 100 knots almost, 115. You can see the airspeed here increasing and the V-speeds. We have V1, V-rotate. We rotate the aircraft. And here we go. Take off. So we have positive rate of climb. Retract the landing gear here. We don't need the landing gear. So you can see we have a positive climb here. So we keep climbing. So you can see the altitude above the ground right now is 1,400, 500, 600 feet. The barometric altitude above sea level 3,500 feet. The rate of climb 4,100 feet per minute. So the ground is 2,400 feet below us. This is very important to remember. Here we will have the airspeed and the stall speed margin. We need to avoid to stall the aircraft to reduce the rate of climb, and also bang roll into the position. So we have the flat position here, some reminders just to balance weight of the aircraft. So you can see how accurate this is for flying the aircraft. We're flying manually right now. We're very close to the stall margin. So use this switch to pitch down the tail of the aircraft or pitch it up if we need. You can see the terrain in front of us. So we go into the first waypoint after takeoff. We need maybe a little more thrust. Maybe retract some flaps now after we have a little bit more thrust. So we have about 25 more minutes for this flight, so we need to be very brief. We're gonna make a short flight. Just after takeoff, you can see we keep climbing. Reduce the rate of climb. Let's increase the airspeed margin. You can see the terrain here simple. You can see outside view of the aircraft here. Where we are. So we're flying in Switzerland. So we have a nice view of the Boeing 777 here. So you can see beautiful view of the Boeing 777 as we climb out away from the going into the first waypoint maybe. So here's an engine view. Here's the wing view. Another wing view. So we go back inside to show you how we climb out here. We climb manually at this time, forgot to mention. You can see the autopilot is off here, and also not displayed DAP symbol here in the primary flight display, and the flight mode announced here. So we're going like that. Keep climbing out. 15,000 feet, 16,000 feet, the airspeed. We need a bit more airspeed here. You can see the altitude, the vertical speed is off, so we climbed. We can set up the vertical speed as we wanted. You can see the flight director and the lateral navigation is on. You only need to set up this next waypoint here. You see the legs. So we're going to this waypoint now. This waypoint flying director. So this is quite helpful if we move this down for seeing the FMC, the flight management computer, otherwise we'll be having a very bad view of that. So you can see the cockpit as we climb out, the thrust position, levers position. You can use the speed here, flight level change. Now we have more modes set correctly, so we track more of the flight to a higher position maybe, just to increase the airspeed. You can see this stall margin here. So we cross 35,000 maybe feet. So we have like 10, 15, 20 more minutes to go for this flight. So we overflying the lake again one more time. We need to be a bit more brief in terms of climbing out. So it's gonna slow us down a little bit if we use the manual. So we turn off the auto thrust like that and use a full thrust like that. Just for climb out. You see the thrust here. We can apply manual thrust now. To increase the rate of climb a little bit, you can see the flight director is the auto thrust symbol is off right now. You can see some margins here. So we crossed 34,000 feet now. We have the chemtrails now, which is gorgeous, very beautiful. Chemtrails here. So we reach the climb out altitude now. We need just to level up a little bit. So we call like that. Decrease the thrust a little bit maybe. We don't need so much thrust. You can see the thrust strength here. The airspeed is increasing. So now we fly completely manually, both thrust and pitch and roll. Using the bang roll from the control column and wheel here. We need to adjust pitch down a little bit. Not pitch over our position. Leveling off, it's not easy. Another nice outside view. Have maybe like so this is the Boeing 777-300 ERX from 35,000 feet. Some beautiful views here, the chemtrails and contrails. So of course another margin, 36,000 feet, overflying the lake here. This is Boeing 777, trying to level up a little bit, 37,000 feet. Trying to level up a little bit. So this is a fly-by-wire aircraft, can level up quite well. So we're gonna start turning back into the airport in a while. Just setting up a little bit higher altitude for a cruise. 38,000. So maybe we're gonna start turning in like a couple of minutes. We have 15 more minutes for this flight. We need to descend back to 35,000 as we turn. So we're gonna turn like that. Make a nice turn. So here we are, 29,000 feet, almost 30,000, like 9,000 meters. We are just 300 meters below. We are 930. We are 8,700 meters. 8,700 meters above the ground level. Quite high for this aircraft right now in this configuration. So we're going back to the airport. So we are flying Germany here, the Munich region. So we're going back to lower altitude. So this is our spacecraft for tonight. The Boeing 777-300 ERX. So we're going back side again. Maybe we need to connect the autopilot now. So we use this switch here. We're gonna see, and also the button here, 39,000 feet. Then decrease the altitude to 35,000. We press the switch so we descend a little bit. This is the autopilot message here connected. So we're gonna have maybe going direct into the airport for saving some time. Proceed direct to and execute and fly direct into the final fix. 29,000 feet. There is a higher airspeed here. Descend a little bit to lower altitude. Have maybe like 15 more minutes left. So this video actually is much more, but yeah, we have like 15 minutes left for this flight, so we need to be brief. So we need only to set up one last thing for the landing to the airspeed. So this is the landing airspeed selected and the flat position. 35 degrees and 154 knots plus 5. The correction, you can see we're gonna land in this runway, this airport, Lszh, Zurich International, 10,837 feet, runway 14. 3,300 meters, gross weight 238.3 thousand kilograms in landing. So you can see now we have the automatic thrust, we have the autopilot here on, now we have the altitude hold, the airspeed hold, and the heading in any map. Hatsios and the autopilot is on. We're gonna level off now, 35,000 feet, and just start descending a while. We're just 43 nautical miles away from the airport. So we have a nice view now with the chemtrails here, as you can see. And the chemtrails, so here we are. Just 15 more minutes. You can see the vapors from the engines of the Boeing 777-300ERX. So we are flying straight again in Switzerland. We left Germany valley behind us. So this is our spacecraft for tonight's flying. You can see the galaxy here. We're flying 35,000 feet above ground level. The Boeing 777 spacecraft tonight. So we go back inside and start, you can see how close we are, just 34 nautical miles away again from the airport. So decrease the airspeed, we're gonna initiate the descent now. So decrease the altitude also, and use the vertical speed. With some speed breaks here, we need to slow down the aircraft because this has a lot of airspeed. So this is Mach 0.7 and a half, 0.22 right now. We have a higher Mach speed, 0.76 or something like that. You see the modes here: engage, so I say primary flight display, fly mode, and auxiliary speed, and nav and vertical speed. The autopilot is on. Rate of descent into this selected altitude 6,000 feet and the airspeed 215 knots is decreasing, or Mach 0.697 right now. You see the heading, barometric altitude setting 39.92. We have terrain, traffic alerts here. We have one more aircraft here. You can see flying 5,300 600 feet above us. You can see the runway here of the airport. And the final shape we're gonna fly over. So we crossed 32,000 feet now. Keep descending. We have like 10 more minutes for this flight. So we need to be a bit brief. Ναι, τώρα έρχομαι. So you can see our beautiful aircraft, the Boeing 777. Maybe turn off the lights so you will see we also have the landing lights here. You can see the panel here. You can see the rate of descent, 17,600. So we need to slow down a little bit, increase the rate of descent, just 16 nautical miles. We are in a good, nice position for landing like that. This triangle. You can see here as we descend. We also have the galaxy here. So this is our beautiful Boeing 777-300ERX. You can see the galaxy now. We need about 13 minutes to complete this flight, maybe less. The way we descend and we fly, I'm gonna use some manual flight modes. You can see the airport here. How we descend. Maybe decrease the airspeed even further. We need a little bit slower, extend the landing gear maybe. Slow us down. So this is gonna slow us down a lot. Landing gear. Still quite high, so we're gonna make a shortcut for this landing. Just land faster because we have not much time. So you can see here. Keep descending here. 11,000, maybe a little bit higher, right? Like 4,000 feet. So we're gonna use some flaps now. I'm not big, like a minute or two. We need to come over this final fix. And we have like 10 more minutes to go for this flight. So we're gonna use some flaps in like a minute or two. And we need to slow down. We're also gonna use the VOR localizer here to make an Lszh landing and slow down the airspeed a little bit. Like a landing airspeed. So we're gonna use some more flaps here. Need to disconnect the autopilot with just 6,000 feet and overflying the river. We're gonna fly manually again. And use a little bit more full flaps. $5,600. We are in the right position actually for going into landing. You see as we bang roll here, we are in a good. Here is the Lszh localizer. Here is the vertical glide slope. We need to descend with this rate of descent. So we have the flight director on. The Lszh is on. So we're gonna have the runway display. You can see we have the river here. We have the terrain. We're gonna fly over. So we are 4,000 feet. So here we go. And on the landing lights, we need to align. You can see the runway in front of us over here. So we have the Lszh localizer again. You can see the airspeed here. We use automatic airspeed, so we need to turn a little bit to the left, just to align with this line here with the runway, and descend a little bit further. You can see where we are now, our position. So this is how we're gonna touch down into the runway. I need only to align a little bit to the left side. So we have a few more minutes to go, a couple more minutes. Now we are almost aligned with the Lszh localizer. We have automatic thrust and manual control of the flight controls. So we fly the aircraft manually. So you can see here the Lszh again is to the right now. We turn the aircraft to the right. The vertical glide slope is pretty much good, and here's the runway. We need to align with that. So here we are in alignment. We're gonna use some rudder also. So you can see we are 900 feet above the ground level, 800, keep decreasing the rate of descent and the altitude above the sea level. So we need to hold a little bit as we're going down to the runway. Align again. How close we are to the ground. "300 feet, 200, 100, 50, 30, 30, 10. So here we go. Beautiful landing, parking brakes, reverse thrust, gorgeous landing. So we made a very nice landing for this aircraft. We're slowing down. You can see the landing gear. We can take off again here. The takeoff, go around, flight director, everything set for a go around if we need. You can see here in the menu displays synoptics. So we have, you're gonna see the tires here are okay. The landing gear here, I believe you can see, is in good position. There is no breakers anywhere, and the nose wheel also, and both landing gear. So I'm gonna show you the systems later are all okay, functioning quite well. So you can see the landing gear again from the back. Another view. The nose wheel here, very important, is in good shape. Over here you can see the nose wheel of the aircraft. Wheel gear is safe. So if I'm gonna show you the landing gear inside, you're gonna see it's safe. So we made a nice landing here. You can see where we are. One more time, and then I'm gonna take the video. So I'm coming inside here again. You can see the thrust reverse is activated. So we need to show you some of the systems. You can see the doors are closed and pressurizing the cabin, and the landing gear, the tires, and the nose wheel, and the landing gear and the brakes temperature is fine. There's no problem. So you can see the electrical, no problem. All feeding, the hydraulic, no leakage from this flight. All is normal. The fuel, no leakage, and the fuel into the engines, no leakage from landing. Air system, no leakage, normally working. The flight controls, you can see everything working. Elevator and rudder. and the checklist, which is normal. Normal, there's no problem with this aircraft. So that was Thomas Hatsios, the pilot captain flying the Boeing 777-300 TRX. Thanks for joining me in this flight. We just flew with the Boeing 777-300 TRX over Switzerland and Germany. Zurich International Airport runway 14 as always. So I'm gonna see you in another flight. Bye bye. Thank you very much for joining me. Bye bye. How do you make